Okay, hello. Today we're going to be continuing section 3.5. This is section 3.5, part 2. And we're going to start with number 7. So this is going to be talking about another way to come up with a quadratic formula. The formula itself is, again, it's a little complicated. So make sure that if you're not understanding that you ask your teacher. Okay, we're going to start here with number 7. You may have found the algebra for writing the general quadratic function, this one, in vertex form a bit difficult. So that's talking about number 5 and number 6. Here's another way we can work with the general quadratic function leading to the same results that you would have arrived in 5D. So this is another way to do the same thing that we did in question 5. Okay, so it starts with, since the two x-intercepts are d units from the line of symmetry x equals h. This is going to be very important. So the line of symmetry is at h, right? Whatever h is. It could be anything, but whatever h is, there's the line of symmetry. And the two x-intercepts are going to be on the left and on the right of h. So if h is in the middle, then you're going to have an x-intercept on this side and one on this side, right? And then the space between them, that's d and that's d. So we could say it's h minus d, comma 0 and h plus d, comma 0. These would be your 2 points. Whatever h and d are, these would be your points. Okay, so we can always write the factor form of a quadratic if we know its x-intercepts. The factor form will look like this. Okay, we remember factor form. And then p and q are the two intercepts. So using this information, write the factor form of the general quadratic using the fact that x-intercepts are h minus d and h plus d. Okay, so we know that the x-intercepts are this and this. That means that the factored form is going to look like this. F of x equals a times x minus h minus d and x minus h plus d. Okay. So these would be your, whatever this is here, right? H minus d, that would be like a number, right? H minus d might be 5 or h minus d might be 7 or whatever. That would be one of your x-intercepts and this would be the other one. And so those two numbers go here and that makes your factor form. Now it says multiply out the factor form. You will be multiplying two trinomial expressions together to get the quadratic in standard form. Simplify a result as much as possible by combining like terms. So we're going to multiply this out. We're going to start by multiplying the parentheses together. I'm going to go ahead and use just the FOIL method, or yeah, just the FOIL method. So we're going to say f of x equals, we're not going to multiply the a in just yet, but we would get x times x, which is x squared. We would get x times negative h plus d. So this would be minus x times h plus d. And so that x spread here and it went to here. And that's that one done. So now we go to here. This is going to distribute to here and to there. So negative h minus d is going to multiply to x. That's going to give us negative x times h minus d. And then that will multiply here. And we've got negative times negative, so that'll be positive. And it'll be h minus d and h plus d. Okay, so now we can keep distributing. So we're going to distribute a little bit more. The a stays. X squared stays. We're going to distribute here. Negative x times h is negative xh. Negative x times d is negative xd. And then we'll distribute here. Negative x times h is negative xh. And negative x times negative d is positive xd. Okay, and then multiplying these together, we would have to use the same format. So h times h is going to be h squared, positive. H times d is going to be dh, and that's positive. Negative d times h will be negative dh, and negative d times d would be negative d squared. Okay, now in here, I see minus xd and I see plus xd. So that will cancel out. I also see plus dh and minus dh. So those will cancel out. And then I can also distribute this a as well. But before I distribute the a, I notice these are the same. So I'm going to combine them. We get a times x squared minus 2xh. And that's those put together, plus h squared minus d squared. So there's h squared and there's d squared. And then now we can distribute the a. So this would equal ax squared minus 2ahx. I'm purposely reorganizing these letters to make the x the last letter there. And then plus a h squared minus a d squared. Okay, so this is the regular format. All right, let's keep going. It's as simple as possible. Okay, so now we're going to talk about question C. It says you now have the same general quadratic function written in standard form in two different ways. One where the coefficients of the terms are a, b, and c. So that looks like ax squared plus bx plus c. Right? So that's one way we can write it. And then the other way we can write it, which we just wrote, is to write ax squared minus 2ahx plus ah squared minus ad squared. So the a is just a. What we're gonna do is match these up. So a is just a. B is whatever's in front of the x. So what's in front of the x is this. So this would be b. And then c is everything that's left over. So all of this put together, that's all c. Okay. It says match up the coefficients. We did. That is b, the coefficient of x in one version of the standard form is equivalent to negative 2ah in the other version. So likewise, c, the constant term in one version, is equivalent to ah squared minus ad squared in the other version. So that's what we just did. We matched them up. Solve the equations. B equals negative 2ah and c equals ah squared minus ad squared. For h and d, work with your equations until you can express h and d with expressions that only involve a, b, and c. So we're going to solve these two equations for h and for d. So we'll start by solving this equation for h. So all we need to do is divide by negative 2 and a on both sides. This divides out here, and you get that h equals negative b over 2a. Okay, remember before when I said that h, oops, here we go. Remember before when I said that h was the line of symmetry? Right, over here we said h was the line of symmetry. Well, we just showed that the line of symmetry is negative b over 2a, which was what we showed the last time when we tried to write the quadratic formula, right? We said that it was negative b over 2a. Okay, now let's try to see if we can figure out what d is, the distance from the line of symmetry. Because remember what I said before was that if you have a line of symmetry, let's pretend my pen is the line of symmetry. If you start with your line of symmetry and you go enough one way and enough the other way, so you have 2 points on either side, those will be your line, those will be your x-intercepts. And so the distance that you're moving is called d. So what we're trying to figure out is how big is d. So let's solve this for d. C equals ah squared minus ad squared. H, we already know, is negative b over 2a. So c equals a times negative b over 2a squared minus ad squared. If we square negative b over 2a, that means negative b over 2a times negative b over 2a. The negatives cancel out, and you get b squared and 4a squared. So we get c equals ab squared over 4a squared. minus AD squared. So what we can do is we can actually, remember, we want to solve for D. So let's move it over to the other side. We're going to subtract this from both sides. So we're going to subtract it from this side, and we're going to subtract it from the other side. That's going to be C minus AB squared over 4A squared. And that's going to equal negative AD squared. Now what we can do is divide by negative A on both sides. So we get C divided by negative A minus or plus B squared over 4A squared equals D squared. Let's make a common denominator here. So what we can do, when you have a negative in a fraction, you can swap it between the top and the bottom. So let's put it on the top. Let's leave the bottom positive. And let's make a common denominator. So here we have 4A squared. So in order to make a common denominator, we can multiply this by 4A and this by 4A. So this would be minus 4AC over 4A squared plus B squared, like that. Because they have this same common denominator, and then that times that equals that, and then B squared. Now we can take the square root of both sides. And we can't take the square root, we can't simplify the top, but we can simplify the bottom because the square root of 4 is 2 and the square root of A squared is A. So we get that D equals, maybe I'll write it on the right. Let's cancel that. Let's write over here. D equals plus or minus the square root. Let's swap these. So B squared can be on this side. B squared minus 4AC. And the square root of 4A squared is 2A. So if we take the line of symmetry, which is here, and we add this, or if we subtract this, we get the two x-intercepts. And that's going to mean that our x-intercepts are negative B. Oh, also notice that they have the same common denominator. So we can put the numerators together. We can say negative B plus or minus B squared minus 4AC over 2A, like that. So based on this work, how can you find the x-intercepts of any quadratic using only the values for A, B, and C? All you have to do is plug them in, right? If you know the coefficients, you label your coefficients A, B, and C. You label them just so that you know where to plug them in over here, and then you plug them in and you can solve them. How does your answer to E compare to the result in 5D? It's the same, right? It's the same formula. All of the functions that we have worked with on this task have had graphs that open upward. Would the formula work for parabolas that open downward? Tell why or why not using the example that you create using your own values for the coefficients of A, B, and C. So yes, it still works. And the reason why it still works is because if the graph opens down, all that means is that A is negative. And if A is negative, what we can do is we can just swap that up here. So the positive would become negative and the negative would become positive. So all that does is it changes this. But since we're still adding and subtracting, it would be the same either way. So for instance, yes, it still works. Let's say that I had the function f of x equals negative x squared minus 4x minus 4. So A would equal -1, B would equal -4, and C would equal -4. If I plug that into this formula, I get -b, so -4 is 4, plus or minus the square root b squared, so -4 squared is 16, minus 4 times a times c. So 4 times -1 times -4. You're multiplying it by negative twice, so it's going to be positive. 4 times 4 is going to be 16, so we still have a 16. And then over 2a, which would be 2 times -1, which is -2. 16 minus 16 is 0. So you get 4 plus or minus 0 over -2. And so it still works, right? You can still get answers that way. Okay. It's important that you understand the quadratic formula, right? So make sure that you understand the quadratic formula. Make sure you understand where it comes from, how it was created. And if you don't understand it, ask your teacher. Please, please, please make sure you understand it. Okay, let's do some ready, set, goes, and then we'll be done. Okay. While working with areas is something essential to convert between units of measure, for example, changing from square yards to square feet and so forth, convert the areas below to the desired measure. Hint, area is two-dimensional. For example, 1 yard squared equals 9 feet squared because 3 feet along each side of a yard equals 9 square feet. Okay, so 7 yards squared equals how many feet squared? Well, if you have 7 yards squared, let's talk about how much is 1 yard squared, right? So 1 yard squared like this means you have 3 feet on each side, right? And so that would equal 9 square feet. So if one is 9, then 7 would have to be 63. So this would be 63 feet squared. Okay, 5 feet squared is how many inches squared? Well, 1 foot, right? 1 foot, if I did a square where it's 1 and 1, this would be 12 inches on this side and 12 inches on that side. So how many square inches would it be? Would be 144. So 1 foot equals 144 inches squared. 1 foot squared equals 144 inches squared. So 5 feet squared, you would say would be 144 times 5. That's 500, 720. Okay, 1 mile squared is how many feet squared? Okay, well, we need to know how many feet are in a mile. I can look that up right now. Time for some Google. Feet in a mile. Feet in a mile. It's loading. Okay, I'm gonna let that load on my. Oh no, here we go. So in 1 mile, 1 mile equals 5,280 feet. So hold on 1 second. There's a noise outside. Okay, so 1 mile is 5,280 feet. So if I have a square mile, that means this way there's 5,280, and this way there's 5,280. So how many square feet are in there? Well, we can take 5,280 and square it. 5,000, yeah, 280, and that's going to be 27,878,400 square feet. Okay. 100 meters squared is how many centimeters squared? Well, 1 meter is 100 centimeters. So if you have 1 square meter, that would mean it would have 100 centimeters going this way and 100 centimeters going that way. So that would be 100 times 100, which is 10,000 centimeters squared. So if I had 100 of these, I would have 100 times this, which would be this with 2 zeros extra added to it. So that's 1 million. So 100 meters squared is 1 million centimeters squared. 300 feet squared is how many yards squared? Oh, this is tricky. Okay. So let's see. It takes 9 feet squared to make 1 yard squared, because you have to arrange them like this, and then that's a yard squared. So how many 9s are in 300? 300 divided by 9. So there's 33. Right? There's 33 9s in there. 33 times 9 is 297. And we still would have 3 left over. So that would be 1/3 of this. So it's 33 and a third. 33 and a third. Okay. 96 inches squared is how many feet squared? Well, that's a good shout, because okay, so it takes 144 to make 1. We don't have 144, so we don't even have a full 1. How many do we have? Well, okay. We have 96 out of 144, right? That's how many we have. We have 96. This is what it takes to make 1 full 1. Can I reduce this? 12 goes into this 12 times. 12 goes into 96 8 times. Okay, I can reduce that more. 4 goes into 8 twice, and 4 goes into 12 3 times. So this is 2/3 of a foot squared. If I had this many square inches, I would be able to fill up 2/3 of a foot square. Okay, there we go. All right, let's do the set. Graph each of the quadratic functions. Okay, f of x says x squared. So x squared starts here, the vertex is there, and we can just follow the parent function. 4 and then 9. 4 and 9. Okay, so this is f of x. G of s is x squared minus 9, so that means everything moved down by 9. So that's the vertex goes to here, and then all the other points moved appropriately. 3, 5, 7. Right, that's g of x. Okay, and then h of x has the +2, which means that the vertex moved to the left 2 points. So that vertex is now over here. It's still -9, so it's still down here. And that means all the points move to the left 2. So this point is over here, that point is there. And then we can just follow the parent function. There, right, and that's going to give us this. And this would be h of x. So how do the functions compare to each other? F of x is normal. G of x is translated down 9 units. And h of x is translated down 9 and left 2. How do g of x and h of x compare to f of x? Oh, I just answered that. Okay. How do the functions compare to each other? Yeah, okay. So that's kind of the same question. Look back at the functions above and identify the x-intercepts of g of x. What are they? Okay, so g of x was this one. We've got 3 and negative 3. 3, 0, and negative 3, 0. Okay, what are the coordinates of the points corresponding to the x-intercepts in g of x and each of the other functions? How do these coordinates compare to one another? So these 2 points in h of x, they're to the left 2. So instead of negative 3, it's negative 5. And instead of positive 3, it's 1. And in f of x, those 2 points they're like up there. It's this point and this point. Okay, so f of x, the points are, so this point is up here. It's 9 higher. So it's actually negative 3, 9, and then it's 3, 9. Okay, let's keep going. All right. Graph each of the quadratic functions. Okay, it's asking me to graph again. So here, 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 here. That's f of x. G of x is minus 4, so it's everything is down 4. Here. And h of x has this minus 1, which means that everything moved to the right one. All right, how do the functions compare to each other? Well, and I think this, yeah, so these two are kind of the similar question. If f of x is normal, then g of x is translated down 4. And h of x is translated down 4 and right 1. And that answers both of those questions. Look back at the functions above and identify the x-intercepts of g of x. Okay, g of x was this one. It's at negative 2 and positive 2. What are the coordinates of the points corresponding to the x-intercepts in g of x and each of the other functions? How do these coordinate points compare to one another? So in f of x, the points are 4 higher, so they're negative 2, 4, and positive 2, 4. In h of x, it's the same as in g of x, except they're 1 to the right. So instead of negative 2, it would be negative 1, 0. And instead of 2, it would be 3, 0. How can the transformations that occur to the function f of x equals x squared be used to determine where the x-intercepts of the function's image will be? How can the transformations be used to determine where the x-intercepts will be? Well, what you can do is you can take what you can do is you can take the vertical transformation, like, and this one, it was down 4, right? Take the vertical transformation and then take the square root of it. And that will tell you how far to move. So because this was 4, right? It went down 4. Then the x-intercepts were -2 and 2. And if we recall over here on this other one, if we went down 9, so the x-intercepts were -3 and 3. And then based on that, we just look to see if it moved left or right. So you see how far it moves down. And based on that, then you take the square root of that, and that tells you how far it moves left or right. Or from the axis of symmetry. And then if it translates left or translates right, you can adjust accordingly. Okay, function notation and evaluating functions. Use the given functions to find the missing values. Check your work using a graph. Okay, f of 0. We can plug in 0. 0 is just 0. 0 is just 0. This will be -12. Plug in 2. That's going to be 4 plus 8 is 12. Minus 12 is 0. When does it equal 0? Right? When does this equal 0? Well, it says to check your work using a graph. Let's see if we can do it without using a graph. We can factor it, right? 6 and 2, yeah. X plus 6, x minus 2. So in order for it to equal 0, x can be 6 or -2. When does it equal 20, right? So we get x squared plus 4x minus 12. Subtract 20 from both sides. Okay. Can we factor this? This 32 is 8 times 4? Yes. X plus 8, x minus 4. So it will equal 20 when x is either -8 or 4. We can check using a graph. I'm going to let you check those. Okay, over here, when I plug in 0, what do I get? I get -5 squared, which is 25, plus 2, I get 27. That's the y-intercept. What happens when I plug in 5? 5 minus 5 is 0. Squared is 0, plus 2 is 2. All right, when does it equal 0? So this is basically asking what the x-intercepts are. Let's see if we can do it. So since we're going down, or we're going up by 2, the square root, we're going to take the square root, which is the square root of 2. And then we're going to move to the right. So let me see if I can. I want to use this stuff that we talked about up here. So it's up by 2. If that was all it was, then the points would be square root of 2 and negative square root of 2, right? And since we're moving to the right 5, it would be 5 plus square root of 2 and 5 minus square root of 2. Those would be our x-intercept. When does this equal 16? Let's find out. I can subtract 16 from both sides. Okay, so the square root of 14 is just the square root of 14. And we are moving to the right 5. So it would be 5 and 5. 5 plus the square root of 14. 5 minus the square root of 14. Okay, let's check this one on the graph because I want to show you something there. So we can go to Desmos, which has a graphing calculator. Because this is actually never going to equal 0, right? It never equals 0 because the graph is actually pointing up. And then because it's pointing up and it's moved up, it never crosses the x-axis. So this is actually incorrect, sort of. And this will tie into something else that we're going to talk later. But let's just say that these should have little eyes in them. And we'll talk about that in a different task. Anyway, you can check these on your graphing calculator. Okay. Oh, there's some more. Let's do some more. Okay. This will be better to understand when x is 0, this will be 9. When it's negative, when we plug in -3, we get 9 minus 18 plus 9, so that'll be 0. When does it equal 0? Well, this is x minus 3 times x minus 3. So it'll be 0 when x equals 3. If we plug in 3, it makes it equal 0. When does it equal 16? Let's see. 16 equals x squared minus 6x plus 9. We can subtract 16 from both sides. X squared minus 6x minus 7. Can we factor this? -7 and 1. X minus 7, x plus 1. So it'll equal 16 at 7 and at -1. Okay, let's go to this one. What happens when I plug in 0? All right, plug in 0. 0 minus 2 is -2 squared is 4. 4 minus 3 is 1. What happens when I plug in 5? 5 minus 2 is 3. Squared is 9 minus 3. This will be 6. How about when it equals 0? Let's actually solve this. Okay, so when does it equal 0? We'll move the 3 over, right? Add 3 to both sides. Square root both sides. Add 2 to both sides. So when will it equal 0? It equals 0 when x equals that. When will it equal -3? When will it equal -3? It will equal -3. So I'm thinking about the parabola, right? It looks like this. And the vertex is at -2, -3. So when will, or excuse me, 2, -3, +2. So when will it equal 0? At 2, right? X has to equal 2. If I plug in 2, 2 minus 2 is 0, squared is 0 minus 3. Yeah, that's how you get -3. If you make x equal to 2, then it'll equal -3. Okay, let's keep going. What happens when I plug in 0? I get 5 times 5, which is 25. What happens when I plug in -2? I get 3 times 3, which is 9. How can I make this be 0? Easy, I just need to plug in -5. How do I make it equal to 9? To make it equal to 9, I need this to be 3 times 3. Or -3 times -3. There's two answers. I could either do -2, which will make it 3 times 3. Or I could do -8, which would be -3 times -3. And both of those would give me 9. Okay, last problem. What happens when I plug in 0? I get 1. 1 times 1 is 1. -1 plus 8 is 7. Okay, 2. What happens when I plug in 2? I get 3. Squared is 9. -9 plus 8 is -1. When does this equal 0? Let's find out. Subtract 8 from both sides. Divide both sides by -1. Square root both sides. subtract 1 from both sides. So it equals 0 when you get -1 plus 2 root 2, and it also equals 0 when you get -1 minus 2 root 2. Okay, when will it equal 4? Let's find out. When will this equal 4? And let's subtract 8. Divide both sides by -1. Okay, so we need it to equal 4. So if this is a 2 or a -2, it'll work. So in order to make this 2, if I plug in a 1, I'll get 2 times 2, which is 4. So it can work with a 1. If I plug in -3, then what will happen is I'll get -2 times -2, which is also 4. So 1 and -3. All right, and that is the end of 3.5, everybody. Next time we'll do 3.6. All right, make sure that you're asking questions. Again, these videos are not meant to replace your teacher. They're meant to be just so that you don't get stuck. All right, have a good one. See you next time.